Following on from our previous video, we got to this stage here. Where we've created our circle. It starts in the right place and it rotates in the right direction. So as we press play, you can see it rotates in the right direction. So now all we need to do is move the whole circle up by the radius of A. By the radius of a circle, which is A. So now looking at the red circle, this is our x component. So we need to look at our y component because we want to move the circle up by a radius of A. So add A. So our circle has been shifted up by A in the y direction. Looking at our particle, we will need to add A to the y component of our particle. So now let's check. Our particle is spinning in the right place and it starts in the right place. So now we need to give it an effect that the circle is rolling towards the right. So to do that, we would get this distance here. So this distance here is 2 pi, the radius of the circle, which is the circumference of the circle. So this distance here is the circumference of the circle. So what we're going to do is we're going to cut up into 2 pi equal pieces. So just imagine we're going to cut up into 2 pi equal pieces. So don't forget, B starts at 0 and it ends at 2 pi. So that's one revolution. So if you get the whole distance here cut up into 2 pi equal pieces, and then if you stick a B in here, so as B gets incremented, so let's say B is 3. So sorry, let's say B is 2. Say, let's say B is 2. Let's say B is 2 here, right here. So you can see that it's going to be 1, 2, which is the same as 1, 2, right here. So if you look at this, by the time B gets to 2 pi, if you put this into here, into the B, you can see that, well, these two cancel each other out. You can see that it will have traveled a distance of 2 pi A, which is this whole thing here. So what we need to do, well, if you tidy this whole thing up, it will be A, B. So as B gets incremented, the center of the circle gets moved across in this direction. So we need to add AB to our x component. So hang on. It will make sense if you think about it. It was explained badly. So looking at this circle here, looking at the x component, if we add AB, so now as B gets incremented, we are shifting the whole circle by AB. We're moving it in the x direction, so you can see that. By the way, the particle is stationary. It's rotating around that stationary circle. So now we need to adjust the particle. So looking at the particle and looking at the x component of the particle, if we add AB, so now as the circle moves, the particle moves along with the circle. So hang on, let me zoom out. So you can see that as we rotate the circle, the particle moves along with the circle. So now we need to create our cycloid. Well, we really want to follow the path of that green dot. We want to follow the path of the particle. So let's copy and paste the whole particle. Copy and paste, Control C, and then Control V to paste. Hang on, let me think. So B represents the angle. So change B to T. So T is like a reserved letter, a reserved variable, a reserved letter within Desmos. So it scans through from 0 to 2 pi, 0 to 2 pi. So change all of B to T. So T is a reserved letter within Desmos, and then it will automatically scan through the whole system. Change a B to T. Yeah, that's it. So that's our cycloid there. So now as we press play, it will follow the cycloid. Okay, so the equation of the cycloid is given by this thing here. You can tidy this up and so on. Well, you get the idea, I hope.